From the Center for Advanced Study in the Behavioral Sciences at Stanford University, this is Human-Centered. Today on Human-Centered, current fellow Piyush Tantia, whose work involves using behavioral science and design interventions across 40-plus countries, sits down to chat with former CASBS fellow and design legend himself, Don Norman. The two discuss the evolution of behavioral science in contemporary design practice. We'll trace Don's journey from an early run-in with B.F. Skinner to the study of neural networks and cognitive processes, his time at Apple, his time at CASBS, and more. And we'll hear how these experiences have informed Don's thoughts on how design fails and how it needs to change.
Don, this is truly an honor to be doing this. A huge fan of your work. You're like everyone else. Think your design of everyday things has had a big influence on how I think and what I'm doing. So it's a pleasure to be talking to you.
That's unfortunate because I'm writing a book right now. In fact, I am going to finish it in about an hour, in which I say that the way I say to do things in the design of everyday things is completely wrong. We're dealing with societal issues. The principles in the design of everyday things are very much the principles that are in use today by professional designers. And this is the old-fashioned design, because design essentially was invented as a scheme to make products for industry, as a tool of industry to allow them to sell better products, more products, increase their sales. And if you're going to design something for industry, and as I've worked in industry, I worked at Apple, for example, and we assumed we had tens or hundreds of millions of users. So the way in which you design is very different. You're designing for other people. Now, when we look at the societal issues and we go into communities, that's cognitive. That's like being a colonist. You're going into another foreign country and you're saying, oh, I see what your issues are, and here's the correct way to deal with it. And aren't you happy that I'm giving you the solution? It's like Great Britain going into India and saying, oh, you guys can't govern yourself. So we'll help you. We'll put it in our own government system and you can be our servants, civil servants sometimes, but more just plain servants a lot of the times. And no, I told that story to the Indians and they chuckled. Yes, they did not appreciate it. But that's what we do when we go to societies. And so most of foreign aid has failed for that reason. The experts go in and they study the problem and they write a big, thick report that will say will take 10 years and multiple billions of dollars to solve the problem. And experts are experts. What they write is sensible and intelligent, but they don't understand the people. They don't understand their abilities. They don't understand their resources, their culture. And so they fail. And so I can go on because I have actually just finished a 300-page book about this. So I'll let you be the judge.
I want to come to the idea of human behavior and how that's important and doesn't show up in some of these books and solutions, etc. Right from when you started working in design, at least from my perspective, you've been talking about the importance of understanding human behavior. But I was struck that all these years later, you're still having to do it. But why is it that after all these years, people still aren't understanding the importance of human behavior in design?
Well, I say to my friends in the business of design, and especially what's called user experience or user interface, the good news is we will always have jobs. Because look, I wrote the design of everyday things in 1988, or it was published in 1988. And what did I use as examples? Light switches, water faucets, doors. And I used those because it's pretty simple and I could use to illustrate some of the fundamental principles for these very simple devices. But I assumed that people would read the book maybe, and then we would have better doors and light switch controls. No, they're still just as bad as they were when I wrote the book. So if you can't fix them, if you can't fix doors, you know how to open them. And light switches, you know what lights it controls. Why do you think we're going to fix these other big major issues?
That is a depressing thought, Don.
And the main thing, it's not that people don't understand it. The trouble is, I mean, I don't know how many copies of my book have been sold, roughly 1 million. And I don't know how many people that gets transferred to. It's probably, doubled or quadrupled. That's a tiny percentage of people in the world. So it isn't that these people don't understand or that these people aren't making advances. Computers are much easier to use today than they ever were when I started writing. But that's computers, because computers, there's a fairly small number of people who are trained to do this kind of design. But when it comes to your doors, it's the local carpenter, it's the local designer or architect, and it's hard to make the impact on the world.
Yeah, it's the concentration in the tech industry helps. There are a couple of large players, and if they get it, then.
And on top of that, there's a lot of job changing. That's part of one of the things that happens. But it's interesting. When I was an executive at Apple, we talked about this, especially top executives and top scientists being taken away. And we finally decided, we had a meeting of the vice presidents of research of all of the local companies. And we thought at first we're going to make a pact saying we won't steal people from you. But we got convinced that not only is the pact maybe illegal, but that having people wander about was good for everybody because it spread the knowledge, not the secret knowledge, but the general knowledge you needed to know to do well, and it improved the performance of all of the companies. And so I think the change, as the people spread around in the high tech industry, and not just in Silicon Valley, but people from India come to Silicon Valley and go back, people from Japan and China, people from Europe. And as they spread around the world, this spreads that knowledge, because even though it's a huge industry, the number of people making design decisions is remarkably small.
So when you started talking about this in tech back in those days, in the 80s, how was it received? Like, how did you get this idea to be so successful and ubiquitous, this whole idea of user experience? Because maybe that's something there that we can learn from on other things like this, that we have to change something and change beliefs in large systems.
I won't give you my history, but I started off as an electrical engineer, and by accident, I ended up in psychology thinking, oh, well, okay, I can't build intelligent machines. I'll study the one that's up here, which is not what psychologists did in those days. It's all behaviorism, all run by a man named Skinner at Harvard. And in fact, when I moved to psychology because computer science wasn't being taught at my university. Wait a little while, we'll soon have a department. And but the Department of Psychology was wonderful because they got a new chair who was a physicist. And I talked to him, and he says, you don't know anything at all about psychology. Wonderful. And my first job was at Harvard. And I was introduced to the faculty, and B.F. Skinner stands up and denounces me in my field. How can you study something that you can't see? You can't measure it, you don't understand it. Yeah, Lord Kelvin said that in the 1700s. But what everybody forgets is he didn't say, if you can't measure it, you don't understand it. He said, in the physical sciences that you can't measure. And when you come to behavioral sciences and living beings and people, the most important things are the things we can't measure. Anyway, and so I ended up, and I got a job offer at this new university that's starting in San Diego called University of California, San Diego. And I joined in 1966 before anybody had ever graduated. It was a really interesting university because they started with Nobel Prize winners, and then they hired very senior professors and graduates and postdoctoral fellows. And they started with graduate students and worked their way down. And that's why it became such a very world-renowned university in such a relatively short time, because they started high. And I joined the psychology department in the second year of its existence. And we set up something called the Center for Human Information Processing. In fact, I wrote a textbook called Human Information Processing, where instead of explaining all the experiments that everybody around the world had done and you memorize them, and that's the way psychology was taught. No, Peter Lindsay and I, my co-author, we said, we want to be like a physicist, for example. When I took physics, I wasn't expected to memorize anything. Classical physics, I know F equals ma, and I can derive everything else from it. And electrical engineering, there's a couple of basic fundamentals, you derive everything else from it. So can't we do that in psychology? And that's what we did. And so I'm still using my engineering background in psychology. And this field, human information processing, became cognitive psychology, became cognitive science. And what was interesting is one day I got interested in why people make errors. And I did some studies on that. And then there was the 3 Mile Island nuclear power disaster. And I was called in to see why the operators made these errors. Stupid operators who aren't well trained. I mean, it was obvious that they got the wrong answer. No, the committee I was on decided that the operators were very intelligent. They did the best job possible at the time. Yeah, in retrospect, you can always see things that they didn't see. But if you're there at the time, there's a million things going on. And how do you know which ones to attend to? And if you wanted to design a plant to cause errors, you could not have done a better job. And so I said, oh, wait a minute. I'm an engineer. I understand technology. I'm a psychologist. I understand people. No, I should get into that area, which in those days was human factors and ergonomics. And I started doing work for NASA and aviation safety. And then as the new computers came out, and of course, I was one of the first users of computers in psychology. Even when I was my first job at Harvard, we were running our labs with computers, one of the very first labs in the world to use a computer to control the equipment. And so I was used to these powerful computers, by those standards, and not the ones that were coming out for everyday people. And so my team and I started to investigate making things easier to use. We wrote the book, UCSD, my university, User-Centered System Design, which introduced systems and introduced user-centered. And then along the way, right after that, I took a sabbatical leave, and I was in England at the Applied Psychology Unit in Cambridge. And I couldn't work their light switches or the water taps, or I even got in trouble with their doors. And I was intending to just relax. I had been chair of the psychology department, and I wanted to relax after that experience. And but I just got so infuriated, and I realized that the work I was doing with computers applied here too. And I had been arguing with J.J. Gibson, this perceptual psychologist who would visit La Jolla every summer, I think. And he and I didn't agree about anything, but except that we liked each other and we had fun disagreeing. It was really fun to argue with him. And I realized that his concept of affordance was a key. Because I asked myself the question that I can't use these computers. I can't do this light switches and this, but I get around the world and every day I see new things. I've never seen it before. I mean, it may be a thing like a cup, but it's a new cup. I've never seen this cup or this cup, and they're different. And how do I know how to use them? And I realized affordances was the key. And that's sort of it went on from there. And I just wrote the book, and it was damned by the New York Times. The New York Times book review did a review of the book and said, this is a stupid author who doesn't know what he's talking about. And there's nothing in this book that's new. This is a science fiction author who's writing a book review. I've never heard of him. And so my book was about to be accepted by the Book of the Month Club, et cetera. And nope, not after that review. So it took a long time for the book to get accepted.
And you weren't at Apple yet at that point.
That's correct. The book was 1988. I went to Apple in 93.
And did people in technology start reading it? Is that what happened?
Yes, and actually, the one reason I went to Apple was my students had devised the human interface guideline book at Apple, which was famous, which was done really well, and it was done by people who were my PhD students and also undergraduates. Some of my undergraduates that took some of my courses developed the Macintosh. I didn't know that until we asked the Macintosh people to come and talk to our research group because we think you're doing great work. And one of them came and said, I was in your class. And someplace on that time I went, our research group was doing a bunch of really interesting things. And I got invited to the Center for Advanced Studies in Behavioral Sciences at Stanford. And while I was at Stanford, I also worked with one of my friends, Danny Bobrow, and then Terry Winograd at Xerox Palo Alto Research Center, Xerox PARC. We published a fair number of papers while I was actually at the center. And I also wrote this book. It was Explorations in Cognition. And the picture in the front, you can't see it probably, but it's a semantic network, which is what our group was working on at the time. And it's written by Donald Norman, David Rumelhart, and the LNR research group. LNR, L standing for Lindsay, who wrote that other book with me, N for Norman, R for Rumelhart. And actually, shortly thereafter, we got somebody to do cognitive science. And we started a cognitive science research program, and we invited a whole bunch of postdocs. And one of the postdocs, I remember distinctly giving a lecture to the postdocs about perceptrons and why they were faulty. And one of them said I was all wrong. And he took the chalk away from me, went to the board and showed me why I was wrong. And I love that, by the way. I like it when students show I'm wrong because if I'm wrong, I want to know. And his name was Jeffrey Hinton. And out of that interaction came the invention of neural networks. The perceptron was a one-layer network. And what they discovered, it was Dave Rumelhart and Jeff Hinton, to add a hidden network. And so you had an input network and an output network and a hidden layer. And that's what made it powerful. And I was in the beginning of writing the book, User-Centered System Design. And so I stayed at human-computer interaction, and they moved into what they called parallel distributed processing, and then connectionism, and then neural networks. And Hinton went on to be the main leader of deep learning. I asked him recently, how did deep learning happen? What was the breakthrough that allowed you? And he said, no breakthrough. The computers are like 30 million times more powerful today than they were then. So we can have hundreds of networks, hundreds of layers. But actually, I discovered when I did some research on that's not completely true, because Rumelhart had co-discovered. Turns out someone else discovered it years earlier, but nobody knew that. What's called backpropagation, way of setting the weights on neural networks. And it didn't work when you had 100 layers. And so Hinton figured out a way of making it work, even though he had many, many layers. And that's what made it also possible. So I was just reading an article in the New York Times about Toronto is now one of the hotspots of technology. And the article went on to say, and when you ask around, well, how did this happen? They all say Jeffrey Hinton.
Amazing. So your CASBS year was when you were starting to work on human factors and user-centered design and so those ideas. Is that right, if I follow?
I was doing a bunch of this stuff. Yes, it was a combination, and also the neural networks. So these were all the theses and the research that the neural network people were doing. I'm sorry, the semantic network people. Semantic networks was the last gasp of the good old-fashioned AI approach, which is symbolic reasoning, which is all gone now because now it's all pattern recognition. And it's finding it has flaws, And actually, in the parallel distributed processing books, 2 volumes, I have the last chapter in the second book in which I say, well, I think we ought to bring back symbolic processing. And in addition to the neural nets, because neural nets seem to be powerful as pattern recognizers, but they don't have generalization. They can't reason symbolically. And a lot of us, I remember Rumelhart thinking that maybe the subconscious is a complete neural network and the conscious is symbolic reasoning, which is why we're so slow and difficult at it and limited. But it's also powerful. It's how we make generalizations and metaphors and analogies. And I think and people are now starting to talk about trying to combine the two, because each one has strengths and deficiencies. And the trouble with symbolic notation is it never scaled. You could do wonderful demonstrations of relatively small concepts, but to cover everything people know. But that was for me a very, very powerful year. But between my working at Xerox and developing new ideas and my writing this book, I didn't interact as much with the other people who were at the center of that year. And I was scolded for that. And I said, I appreciate this scolding, but they should realize that I was able to accomplish something I probably couldn't have accomplished by being able to be away from a lot of distractions and focus on writing. In fact, COVID is the same thing. COVID made it possible for me to write this last book in 2 years because I was able to sit at home and type away for days and weeks and months and in the end, years. And still talk to people around the world, by the way, except I didn't have to travel like you and I are talking.
Yeah. So the secret to solving the world's problem is to make sure that you always have a lot of free time and have no distractions, because you will crank out the next brilliant idea if only you have.
Well, there are different ways that people work. Einstein used to say that when he took this job at a patent office, it was the best thing for him because it was there was fixed a set of hours. When he looked at technology, which was even relevant to what he cared about and thinking about, but it gave him all the rest of the time free to think hard about his science. And so if he had a job that occupied him full time, he wouldn't have been able to have been a great scientist.
It's funny listening to you talk about your professional history and all of the work. What's striking to me is it's not as I imagined. And what I mean by that is when I talk to designers, I feel like I'm talking to an artist. When I talk to you, it reminds me of my engineering days. Like I was a computer science major in undergrad, and I used to tinker around with code and electronics, or even in high school. So I want to ask you about these two parts of design. There's the arts side of it, and then there's the analytical engineering, understand human behavior, cognitive science side of it, which you pretty much, I think, brought in. How do these two fit, and how should they fit?
That's another long story. But actually, when you say design and engineering and cognitive science, that's not a normal combination of design. And the problem is that the traditional designers come from most design has been taught in art schools, art and design. And it's all about the appearance. And if you look at the Bauhaus, the famous Bauhaus in Germany, they have this wheel, the topics they taught. And there was material and color and form and all sorts of things. And for example, the use of the objects you're building was never part of what they taught. And there were no people in what they taught. And they made wonderful, beautiful objects because it was really applied art. Well, there's a new kind of design that is erupting, and has been erupting for, you could probably trace it. Great designers always had this broad approach and also trying to approach larger problems, societal issues. But today, more and more of us are trying to do that. And there are I'm friends of many great designers around the world, and many of them are trained in design, but a surprisingly large number of the great designers have no formal design training. They started as a psychologist, they started as an engineer, some of them started as a medical doctor, they started all sorts of things. But it's just like I said, when I became a psychologist, all this engineering background made me a better psychologist. And when you switched fields, oftentimes the stuff that's elementary in field one is brilliant insight in field two. And having this, being able to have different points of view is really valuable, and especially as we hit these more complex issues in design. And one problem is that designers in companies. So in 1971, Victor Papanek, a famous designer at the time, wrote a book called Design for the Real World. And the first sentence of the design of the book says, there is no field more dangerous than design for making all the crap that people buy. Well, come to think of it, maybe there is a field more dangerous. It's advertising, convincing people to buy the crap that they don't need.
Right. That's the real problem, right? If no one advertised anything, no one would buy anything.
That's right. And then he went on to say, here's what we ought to be doing in the other countries of the world and so on. And it didn't go over. Today, he's a hero. Everybody quotes him, but not at the time. But we need different skills to do this. And even the behavioral sciences are often the wrong skills, because behavioral sciences, you mean anthropology, sociology, psychology, those fields look down on you if you do anything that's applied and practical. And so their theories. I discovered this when I got to Apple. I was an expert in all these issues, and I had already written books. And I go to Apple ready to show them how to do things. And I discovered most of the stuff I knew was irrelevant. And where they had real issues, where they could have used really good advice from behavioral scientists, we never thought of looking at that. And then on top of that, when they had a question, here's a problem with the human factors groups. They're asked this all the time. They're in applied discipline. And they say, that's a really interesting question. And they go away and they come back a year later with an answer. And it's a very specific answer to a very specific set of conditions. Well, first of all, the people couldn't wait. The people want the answer in an hour. They'll wait for tomorrow. But that's about it. And second of all, the specificity meant it wasn't very useful. You couldn't generalize. And so we need a different kind of behavioral sciences. And the behavioral scientists want to be right, want to be correct. They want the optimum value, and they do tests to make sure. The difference between two theories is very important. So you do a test to see which theory might be right, and there's a small difference. In design, we don't give a damn about a small difference. If it isn't a factor of 2 to 10, who cares? And therefore, we don't have to do those precise statistical tests. We have to be concerned about biases, which could change your result, but not about, how many you get to run 1,000 people or whatever to do your experiment. And you want the answer right away, because even an approximate answer is better than not having an answer.
So back to muddling through.
Muddling through, well, in some sense, yes. I still, by the way, it isn't fair to say I muddle through completely. I'm a bottom-up, top-down person. I like to do lots of little things and play around with little things and learn little things and try this and that and the other. But at some point, I sit back and I say, what is going on? What is the fundamental principle? And that's where I try to find an overall arching, coherent platform or description. And that's the top-down that then informs my further work. And it's a combination that I found powerful. And as I pointed out, people in business industry think differently than academics. I have found it's really valuable to go back and forth.
Yeah, me too, right? I've been straddling both sides. I never went for my PhD. I was in the process of researching PhD programs that I wound up at Ideas 42 instead, and then worked with academics, build it and do all the work. And you're completely right. It's always, there might be a theory that applies in this practical situation, and then there's this practical problem that should get researched. And when you can get that cycle going, then it's the most powerful. And yeah, and we do use academic methods perhaps too much, is I think what I'm learning from this, is we get hung up on the perfect experiment, where sometimes we should trust, well, let's just try a couple of things.
It depends upon your goal.
Yeah.
People doing theory have to be precise and careful.
No,
But,
we're trying to solve problems in the world. I mean, we sometimes write academic papers, but that's the secondary goal.
If you ask a scientist, one of the problems that there are legislatures that have with scientists, if you ask them a question, you want them to give you an answer. And no, they say, well, it all depends. Or, I think this, but, Henry, he thinks that. And you guys can't make up your mind. But actually, that's not true. Because the arguments are almost always about the details. And there's general agreement about the approach. Climate change. Are there climate change people who are disagreeing with the results of some other study? Of course. But they all agree on climate change. I mean, all the major ones, there's a small percentage of people who will disagree about anything. But it sounds to the outsider that we are in complete disagreement. And so when scientists testify or they go off to do applied work, they have to take a larger perspective and say, well, yeah, I mean, there's 4 or 5 theories to try to explain this, and they're all contradictory. But actually, when I apply each and any of them, the differences among them are not of any importance for practicality. So I can give you an answer. I like to tell people human memory can hold about 5 to 7 items. And if you learn a new item, it bumps out an old item. And I tell them, look, this is the theory of memory that there is not a single academic who would accept it. So it's completely wrong. However, if you're building something, it's a really valuable way of knowing how much people can remember from instant to instant. It's like a friend of mine once taught me to convert Fahrenheit and to Celsius to temperature. Do you know the rule? It's very simple. So, what is 27 degrees Celsius in Fahrenheit? Well, 27 times 2 is 54. Add 30, it's 84. Is that accurate? No, it's the wrong answer.
Yeah.
But how far off is it? A degree or 2.
Yeah.
And I want to know whether I should wear a sweater.
Right.
and
yeah, the 1.8 versus 2 doesn't really matter that much. Yeah.
And divide by, it's really 5 divide by 5 nines and multiply in my head. No.
So should we, you've talked a lot about changing design education, I think a little bit in the book, but I know that's one of your big projects. So I want to ask you about that, but should we also change academic education?
Yes.
For this exact reason, that get academics to be closer to the applied world and the real world.
Well, not really. There are academics in silos. Just like I said, the companies have 2 tracks because the world's expert in this very narrow field is still very important. And so, but the universities have carried silos too far. I think we also need generalists. We need both. People can cut across. And the way to do this is by not organizing by departments, organize by problems. And when you organize by problems, you have to bring people together from different backgrounds. And now some of them will be part of the team, but some of them might say, well, we need to know more in more detail about this particular component, and they can study their stuff in detail. But this means, though, that there'll be a lot of fluctuation. Some people may work in several problems simultaneously. And the problem, suppose we actually make huge progress, well, then we should start a new problem set and maybe dissolve this one or change it. But because when you work in problems, 2 virtues. One is it forces you to collaborate with other people and realize the commonalities and how each field can help the other field. So advances science in a way that's more meaningful. But second, when you teach, right now, when we teach students, they don't know why they're learning all this stuff. And especially since lots of faculty think, well, how can you learn that? How can you do anything in this field unless you know the fundamentals? So we'll start with the history, and then we'll start with the fundamental principles. And the history is boring to people when they're in college. And the fundamental principles, well, I don't know why I'm supposed to learn all this stuff. If you give them a problem that they're really interested in. So my favorite technique is to tell people, I give my students problems on day one and ask them to work on it. And I may have 2 or 3 problems to match the interests of the students. And what I want is I make them give reports pretty quickly. And the reports will be pretty horrible. They'll be wrong and they won't know what to do. And that's on purpose for me. But because what I do then is not criticize them. I say, oh, it'd be really good if you read this chapter of this book that we have assigned anyway. But don't read it until I tell you, because I want you to read chapter 13. And you give them the material they need at the time that they're ready for it. And if I had just ordered them to read chapter 13, they would get nothing out of it. But when they're stuck and it's a chapter that's relevant, they get a lot out of it. And so again, we can try to structure education so it's meaningful. And how do we manage to change design education so people have this broad background that it interests?
And is anyone starting to teach design differently?
A lot of people. So we're trying to build on their experiences. We're trying to find them and bring them in.
Yeah, because you've got these prototypes out there already happening.
That's, I say that in my book too, about the new kinds of design that we need. And I'm saying that there are lots of groups that are doing this. And that's good, not bad. In some sense, there's nothing new in the book. What's new is the framework and approach that I use. And I say, but if you wanted to have a revolution, you need revolutionaries. You need people who've already believed. Bring them together. And so it's good that we have lots of people who have similar points of view. Now, what we have to do, though, is bring them together, because a lot of them are isolated and alone and they don't have much impact.
Don, thank you so much. This has been really, really amazing. Great honor for me to be able to do this.
But thank you. That was a great conversation. So
that was Don Norman in conversation with Piyush Tantia. You can learn more about this episode by checking out the show notes. If you want to learn more about the center, its people, projects, history, and upcoming events, you can head over to our website at casbs.stanford.edu. And if you want to join the conversation with us on Twitter, we're at CASBS Stanford. We're on all the major podcast platforms, so if you don't want to miss another episode or you want to check out past episodes, go ahead and follow us in your podcast app of choice. Until next time, from everyone at CASBS and the Human-Centered team, thanks for listening.